In the last chapter, we had equations, like this one, with two variables in it. And we found that these equations have a lot of solutions, and the solutions are ordered pairs. In this chapter, we're going to compare two equations, this one and this one, both having two variables, and we want to know the ordered pair that work in both. One way that we could do that is create a table of values and just compare them. So if I find some x's and y that work in this equation, let's say, well, 0, 0 works, and 1, 1 works, and 2, 2 works, and compare it to a list of values in this equation. So if x is 1, 6 minus 1 is 5, 6 minus 2 is 4, we right away, or I guess I could do 0 as well, right away see that none of these pairs are exactly the same. But there is one pair that is the same, and that's what we're trying to find. So there must be a better way than just making a list like this. Let's take a look at that way. If I were to graph these lines, I would be able to see a visual picture of all of the ordered pairs that work. And if I'm looking for the ordered pair that work in both, hopefully I can see that one that they have in common. So my method is to graph both of these lines. First line, the slope is 1 and the y-intercept is 0. So here's the y-intercept, up 1 over 1, up 1 over 1, up 1 over 1. And I'm just going to extend my points in both directions. I'm not going to connect with a line yet. This graph, the slope is -1 and the y-intercept is +6. So that's up here. 1, 2, 3, 4, 5, 6. Down 1 over 1, down 1 over 1. Ooh, right here. Down 1 over 1, down 1 over 1. I can see what point these two graphs both have in common. They intersect at the point 3, 3. If I go to the equations and double check that, in the first equation, if x is 3 and y is 3, it works. In the second equation, if x is 3, 6 minus 3 is 3. So this is the point that works in both, 3, 3. Let's try another example. I want to know what x and y pair work in both equations. Now if I want to graph these equations, these are not written in slope-intercept form. So my first step is going to be to rewrite it. In this equation, I'm going to subtract x from both sides and divide by -1. X minus 6. So that is the first equation I will graph. This one, to solve for y, all I have to do is subtract 2x. So these are the two equations that I'm going to graph now. First equation, the slope is 1 and the y-intercept is -6. 1, 2, 3, 4, 5, 6. Up 1 over 1, up 1 over 1. And in the second equation, the slope is -2 and the y-intercept is 0. So 0 here, down 2 over 1, down 2 over 1, down 2 over 1. It looks like my graphs intersect at this point. This is the point 2, 1, 2, 3, 4, -4. Go ahead and double check those in the original equations. So the original equation, x minus y equals 6. 2 minus -4 equals 6, so that one works. And in the second equation, 2x plus y equals 0. 2 times 2 plus -4 equals 0. This is 4. This is -4, so my equation is true. This is the solution. Solve this system of equations by graphing. Well, this first one is already in slope-intercept form. That's nice. This second one I need to rewrite. So my first step is going to be to subtract 4x from both sides. So I have -4x minus 8, and divide everything through by -8. So I'm going to get +1/2. -8 divided by -8 is +1. Here is my other equation. Now, I notice both of these equations are identical in slope-intercept form. That means that any equation that works, or any set of x and y that work in this equation will also work in this equation. If I go through and graph these, I will see that the graphs, not down there, up here, the graphs are going to overlap. Up 1 over 2, up 1 over 2, and that's going to be the same thing here. So there are two lines sitting on top of each other. What points work in both? Well, there's infinitely many. Solve the system of equations by graphing. Neither of these two are in slope-intercept form. So let's start and rewrite it to be that. I'm going to add x to both sides in this one and divide everything by 2. In this equation, I'm going to subtract x from both sides and divide everything by -2. So these are the two equations that I need to graph. Okay, y-intercept of the first equation is 1, and the slope is 1 over 2, 1/2. So that means up 1 over 2. Up 1 over 2, up 1 over 2, up 1 over 2, etc., etc. Go back down this way following the pattern. So there's my first line. Second line has a slope, or has a y-intercept of -4, 1, 2, 3, 4, and has a slope of 1/2 as well. Up 1 over 2, up 1 over 2, up 1 over 2, etc., etc. Well, what do I notice about these two lines? They do not appear to be crossing. Well, am I sure that they're not going to cross somewhere up here and somewhere down here? I am pretty sure that's going to happen because these two lines are parallel. And what do we know about parallel lines? They do not cross. That means there is no pair of x and y that work in this equation that will also work in this equation. Parallel lines have the same slope and they do not intersect. So there is no solution to this system